In this video, I'm going to discuss adding and subtracting radicals. You're going to quickly notice that adding and subtracting radicals is no different than adding or subtracting like terms, or what we call combining like terms, in algebra. So, in this first example, if we were to have 5x minus 3x plus 4x, we're going to notice that all of these are like terms because they have a single x variable with them. So when that's the case, we're just going to do the arithmetic on the coefficients as it's instructed to do. So if we have 5 minus 3 plus 4, all of these are going to be x's, so the x's are just going to come along for the ride. So 5 minus 3 is 2, and 2 plus 4 is 6. So that'll be 6x for our answer right there. Similarly, when we have 5 times the square root of 3 minus 3 times the square root of 3 plus 4 times the square root of 3, all of these are going to be considered like terms because each of these include a square root of 3. So we're going to do the arithmetic on the coefficients just like we did a while ago. So 5 minus 3 is 2, and 2 plus 4 is 6. And the radical 3 comes along for the ride because that's the like term. All of those terms had a radical 3, or the square root of 3, with them. In this next example, we're going to see which of these terms are considered like radical terms, and then we're going to do the arithmetic on the coefficients to essentially just combine the like terms. So this first one is 7 times the square root of 3, and we have 2 times the square root of 5, and then the square root of 3, and then another 2 times the square root of 5. So everything with the square root of 3 is going to be considered a like term because these are both the same, square root of 3, square root of 3. And everything with the square root of 5 will be considered like terms because each one of them has the square root of 5. So I put a single underline under the like terms and a double underline under those like terms. So when we have this now, we're just going to add or subtract the coefficients as indicated. So this first one is 7 times the square root of 3 minus the square root of 3. Remember that there's just a 1 out front of there. If there's no coefficient indicated, it's just understood to be a 1. So 7 minus 1 will be 6 times the square root of 3. And then we have 2 radical 5 plus 2 radical 5. So 2 plus 2 is 4 times the square root of 5. And that cannot be simplified anymore because here we have 6 square roots of 3 and here we have 4 square roots of 5. In this example, we have 7 times the cubed root of 2 plus 5 times the square root of 2 minus the cubed root of 2 plus 2 times the square root of 2. Notice that the radicand, or the number underneath the radical, is 2 in every case. The difference here is that the index, some of these are square roots and some of these are cubed roots. So when you're seeking out like radical terms, the radicand and the index both have to be the same. So the cubed root of 2 will go with the cubed root of 2, but the square root of 2 will go with the square root of 2. So they're all going to be different here. You have the cubed roots here, and then you have the square roots here. Okay, so when you combine like terms, it's going to be 7 and then a minus 1. So 7 minus 1 is 6 times the cubed root of 2. And then over here you have 5 plus 2 will be 7 times the square root of 2. So even though the radicand, or the number underneath the radical, is going to be the same, the indexes were not the same, so they're not going to be considered like radical terms. So now this expression is as simple as it can be. In this next example, I have the square root of 27 plus 5 times the square root of 3. Okay, so I know that 27 and 3 are not like radical terms right now, but I bet I can simplify this square roots of 27. So if I put it over to the side here, my 27, and start to simplify it by dividing out prime numbers, I'm going to see that 27 is really 3 times 3 times 3. So I'm going to rewrite this as 3 times 3 times 3 under this radical, and I'll just bring everything else down. And these 3's will group together and come out, so it'll really be 3 times the square root of 3 plus 5 times the square root of 3. So after I simplify this a little bit, I notice that, hey, they are indeed like radical terms. So I can say 3 plus 5 is going to be 8 times the square root of 3. So sometimes you're going to have to simplify these radicals first to see if they are like radical terms in order so you can add them or subtract them. So if we slide over and look at this next example, I have the cubed root of 8 minus 5 plus 4 times the square root of 2. So when I initially look at this, it doesn't look like anything is going to be in common, because this is the cubed root, this is just an integer, and this is the square root. Well, the square root of 2 won't simplify anymore, but I wonder if this cubed root of 8 will. So if I do 8 over here on the side, I'll divide out a 2, and I get 4, divide out another 2 to get 2, and divide out a final 2, I get 1. So I can rewrite this as the cubed root of 2 times 2 times 2, and then everything else just comes along for the ride. Okay, well if it's a cubed root, I'm looking for groups of 3, which, hey, there's a group of 3 2's, so those 3 2's will come out to make a 2 on the outside, and every number inside of this radical was part of this group, so there's no numbers left over, meaning there's no radical left over. So when I bring the rest of it down, I notice that, hey, now I have some like terms I can put together. 2 minus 5 is negative 3, and then plus 4 radical 2. So in this case, again, once I simplified some things down, I did have some like terms and I was able to combine them together.